Hello everyone, my name is Kenneth George Fernandez and this is the presentation of Group 1. Our chosen topic is all about the Bernoulli distribution. But before that, let me introduce to you first our group members. First, our leader, we have Rolling Me yours truly, Kenneth George P. Fernandez, Elmer R. Velayo, Charming A. C. Hasan, Ako ang inatasan ng aking ka-groupmate sa definition and the formula of our chosen topic which is Bernoulli distribution. Pag sinabi natin Bernoulli distribution, it is a discrete probability distribution for a Bernoulli trial, a random experiment that has only two outcomes. Yung two outcomes na yun ay usually tinatawag nating success or failure. For example, the probability of getting ahead, that is our success, while flipping a coin is 0.5. The probability of failure is 1 minus P, or 1 minus the probability of success, which also equals 0.5 for a coin toss. It is a special case of a binomial distribution for n is equal to 1. In other words, ang binomial distribution daw is a single trial or a distribution with a single trial. Next, proceed tayo sa formula. The probability distribution is computed by P of x is equal to P raised to x times the quantity of 1 minus P raised to 1 minus x, where ang P natin is the probability of success, RQ, it is the probability of failure, which is, kung mapapansin nyo, wala tayong Q sa ating formula, but that is equivalent to 1 minus P. We have the X, it is the value or outcome. Usually, it is X is equal to 1 or X is equal to 0. We also have the mean, variance, and standard deviation of the Bernoulli distribution. First, the formula of our mean is mean is equal to P. Our variance is equal to P times the quantity of 1 minus P. And the standard deviation is the square root of P times the quantity of 1 minus P. Okay, the next part is all about the properties of Bernoulli distribution.
Hello everyone, my name is Rolling Me and I'm going to discuss the properties of Bernoulli's distribution. So in Bernoulli's distribution, we have three properties. First is there are only two possible outcomes. It's either 1 or 0, or let's say it is the success or failure in each time. So when we say success, it is the things that you want to get in your experiment. Then when we say failure, it is the things that you didn't get in your experiment. So that is the first property. And the second property is that if the probability of success is P, then the probability of failure is 1 minus P, and this remains the same across the successive trials. So for the success, the value of our x here is 1, and the probability of success is denoted as P, while failure, or the value of our x for failure, is equal to 0, and the probability for failure is denoted as 1 minus P, or Q. And for the last property of Bernoulli's distribution is the probabilities are not affected by the outcomes of other trials. Which means that the trials here are independent, not dependent. It's because the probabilities are not affected by the outcomes of other trials or the trials itself. So hope na naintindihan. So this is my topic, the properties of Bernoulli's distribution, and I will end here. And for the next video, or for the next presenter, it is the application of this topic, the Bernoulli's distribution. So hope na madami pa kayong maintindihan. So that's all for today, and bye-bye!
We'll proceed with the first problem. With this problem, we won't be dealing with any computations, but instead, for a given problem or a probability problem, we need to determine if it is under Bernoulli trial. So, for this problem, we have 8 balls are drawn from a bag containing 10 white and 10 black balls. Predict whether the trials are Bernoulli trials if the ball drawn is replaced and not replaced. So we have 2 cases for this problem. For the experiment wherein the ball is drawn with replacement, and for another experiment wherein balls are drawn without replacement. So for the first case, when a ball is drawn with replacement, so when we say replacement, when we draw a ball, we put it back into the container and then we draw another ball. So that is for with replacement. So for example, the probability of success is drawing a white ball. So based on our given, the probability will be 10/20 or equal to 1/2. Since this is with replacement, so if we draw another ball until we get 8 trials, we'll have the same probability of success. Thus, the trial involving drawing of balls with replacement are said to be Bernoulli trials. For the second case, wherein a ball is drawn without replacement. So in here, when we draw a ball, we won't be putting it back to the container. Thus, the number of balls will be reduced. So we'll have the same example wherein the probability of success is drawing white ball. For the first trial, the probability is 10/20 or 1/2. On the second trial, the probability of success will be 9/19 until we reach 8 trials. So we'll notice that you won't have the same probability of success. Thus, the trial involving drawing of balls without replacement are not Bernoulli trials.
Problem number 2. Approximately 1 in 100 Korean adult is doctor. 1 Korean adult is randomly selected. What is the distribution of the number of doctors? So to solve this problem, we have to let x is equal to 1 if a success occurs, and x is equal to 0 if failure occurs. Then x has a Bernoulli distribution. We have P of x is equal to P raised to x times the quantity of 1 minus P raised to 1 minus x. Since doon sa ating question or sa problem natin, we have P is equal to 1/100, we have to substitute 1/100 sa ating formula. So ngayon, meron na tayong 1/100 raised to x times 1 minus 1/100 raised to 1 minus x. So, to determine the probability of our success, we have to let x is equal to 1. So, lahat ng x sa ating formula is papalitan natin ng 1. We have now 1/100 raised to 1 times the quantity of 1 minus 1/100 raised to 1 minus 1. So, if gagamitan nyo ito ng calculator, ang result is 1/100. Therefore, we have 1/100 probability na yung mapipili sa 100 Korean adult is a doctor. Okay? Next, we have for x is equal to 0, isubstitute naman natin yung 0 sa x natin. So we have 1/100 raised to 0 times the quantity of 1 minus 1/100 raised to 1 minus 0. So, if you are going to calculate this using the calculator or using your mind, we have the result 99/100. Therefore, the probability na hindi doctor yung Korean adult na mapili natin is 99/100. So that is problem number 2.
Problem 3. A sided pair die is toast. With each element in the sample space heaping the probability of 1/6. Find the distribution the mean and the variance if the value 5 occurs. P is equal to 1 over 6 since the value 5 occurs once. Let's substitute this with our equation, which is P of x is equal to P raised to x times the quantity of 1 minus P raised to 1 minus x. So we have 1 over 6 raised to x times the quantity of 1 minus 1 over 6 raised to 1 minus x. So we have 1 minus 1 over 6 is equal to 5 over 6. Then x is a Bernoulli distribution of P of x is equal to 1 over 6 raised to x times 5 over 6 raised to 1 minus x. Let's compute for the probability of success and probability of failure. For the probability of success to occur, let's substitute x with 1. So we have P of x is equal to 1 is equal to 1 over 6 raised to 1 times the quantity of 1 minus 1 over 6 raised to 1 minus 1. So we have the probability of success of 1 over 6. For the probability of failure, let's substitute x with 0. So we have P of x is equal to 0 is equal to 1 over 6 raised to 0 times the quantity of 1 minus 1 over 6 raised to 1 minus 0. So we have, for the probability of failure, we have 5 over 6. Since P, or the probability of success, is equal to 1 over 6, let's compute for the mean. Mean is equal to P. So we have mean is equal to 1 over 6, which is 0.166. For the variance, we have variance is equal to P times the quantity of 1 minus P. So substitute the value of P with 1 over 6. So we have 1 over 6 times 1 minus 1 over 6. So 1 minus 1 over 6 is equal to 5 over 6. We have the variance of 5 over 36 or 0.1388. That's all.
Problem number 4. Find the mean, variance, and standard deviation of the following Bernoulli distribution. We have our x, success, and our failure. Our success is 1 and our failure is 0. And f of x, we have our success 1/4 and our failure is 3/4. As we continue, solution for this problem, we have find the mean, variance, and standard deviation of the following Bernoulli. We have x, our 1, of course, our success, 0. Then p of x, 1/4. And our failure is 3/4. Our p is 1/4. Then our q, or 1 minus p, is equals to 3/4. Our mean to solve, we say that our u, or mean, is equal to our p, it's our success. So our u, or mean, is equals to 1/4. Then another, we solve for our variance. So we have sigma raised to the power of 2 equals p times 1 minus p, or our qp times q. So sigma raised to the power of 2, 1/4 times 3/4. The answer, sigma raised to the power of 2 equals 3/16 equals, we make it decimal, so 0.1875. So that is our variance. And another, we solve for our standard deviation. Of course, we square root. We derive our sigma. So we have sigma equals square root of p times 1 minus p, or our q. And sigma equals square root of 1/4 times 3/4. So, and our outcome is sigma equals square root of 3/16. And converted to decimal, we have 0.43. Thank you for watching sa Amon. Padayon lang.
The last problem we have is find the main, variance, and standard deviation of the following Bernoulli distribution. Given na yung probability of success natin at saka probability of failure. So our probability of success is 0.30 while the probability of failure is 0.70. Now to get our main, variance, and standard deviation, so we have P, or the probability of success is 0.30 while the probability of failure is 0.70. Now to get our main is equivalent to probability of success. So ang probability of success natin is 0.30. Therefore, our main is 0.30. For the variance, we multiply probability of success and probability of failure. So, the probability of success natin is 0.30 times probability of failure is 0.70. So, if we multiply, we have 0.21. Hence, our variance is 0.21. For the standard deviation is the square root of variance. Ang variance natin kanina is 0.21. So, if we take the square root of 0.21, we have 0.46. Therefore, our standard deviation is 0.46.